Hello everyone. Today we are going to be starting section 8.5, which will also be split into 3 parts. And this section focuses on graphing the other trigonometric functions, tangent, cotangent, secant, and cosecant. And this lesson is going to focus on graphing tangent. Let's use the unit circle to think about the tangent function. Tangent is sine over cosine. So we know that tangent will be undefined for any values where cosine is going to be equal to 0. On our unit circle, that occurs when x is equal to pi over 2 and when x is equal to 3 pi over 2, or any odd multiple of pi over 2. Because it is undefined at those values, you will have asymptotes at those x values because tangent will be undefined for those values. Because the tangent function is undefined at these odd multiples of pi over 2, our domain of tangent is going to be all real numbers except for those multiples of pi over 2. And the range is going to be all real numbers. Functions do not have a minimum or maximum. And as you can see, for each section, the ends of the graph approach those asymptotes and they are going to go on forever and ever, all the way to infinity and negative infinity. We also want to take note of the values where tangent is equal to 0. So these are the values where sine is equal to 0 and cosine will be equal to 1. That occurs when x is equal to 0 or 2 pi and when x is equal to pi. So any multiples of pi. And at those multiples of pi, this is going to be an X intercept on our graph. The period of the tangent function is going to be pi units. So a cycle of this graph is completed in pi units. As you can see over here, the sections in between the asymptotes are a pi unit long. Half of the function occurs on the left side of your x-intercept, and then the other half occurs on the right half of the x-intercept. Next, let's talk about graphing tangent. So for our intents and purposes, we're only going to be concerned with graphing tangent functions with vertical stretches or shrinks and horizontal stretches or shrinks. So we don't have to worry about the other transformations. Very similarly to sine and cosine, when your function is in this form, y is equal to a tan bx, your a value is going to represent vertical stretch or shrink, and your b value is going to represent horizontal stretch or shrink. So from before, we want to identify the period of the function. In order to find the period of your graph, you will want to take pi divided by b. When you have a tangent graph, your vertical asymptotes are going to occur at multiples of half of your period. So for instance, like for our parent function, tangent of x, the period's pi. If we take half of pi, we get pi over 2. So the vertical asymptotes will occur at multiples of half of pi. For instance, if our b value is 4, then our period is going to be pi over 4. And in order to find where the vertical asymptotes happen, we want to take half of that pi over 4, which is going to be pi over 8. Vertical asymptotes are going to occur at odd multiples of pi over 8. So pi over 8, 3 pi over 8, 5 pi over 8, so on and so forth. So when you're graphing your tangent functions, there are 5 key values that you need to use to sketch your graph. You want to graph the x-intercept. So these are the x values that make your tangent function equal to 0. You want to graph your asymptotes, which you found in the previous step, by taking half of the period. We also want to find the x values that are halfway between the x-intercept and the asymptotes. At each halfway point, the value is going to be either your a value or negative a. So on the right-hand side, it's at halfway between your asymptote and your x-intercept will have a value of positive a. And on the left-hand side, halfway between your x-intercept and your other asymptote, the value will be negative a. We know how to find these 5 key x values. Let's graph tangent. For example, when we are going to be graphing one period of our function g of x is equal to 2 times tangent of 3x. And we want to describe the graph of g as a transformation of the graph of our parent function tangent of x. Let's first start off by finding the period. In order to find the period, we take pi divided by our b term, which is 3. So we have a period of pi over 3. We next want to find the vertical asymptotes, and the vertical asymptotes are going to occur at multiples of half of our period. So we want to take our period and multiply it by 1/2, and we get pi over 6. So all of our vertical asymptotes are going to occur at odd multiples of this pi over 6. So I've marked up pi over 6 on my graph, and we are going to draw some vertical asymptotes at those x values. And we are only asked to graph one period of our function, so we only need to graph one section. We next want to find the x-intercept, so at which point does the function cross the x-axis? And we know that tangent of 0, because at 0, sine 0 and cosine 1, tangent of 0 is going to be 0. So we know that our x-intercept occurs at the origin. Lastly, we just need to graph the x values that are halfway between our x-intercepts and the asymptotes. And we know that at each halfway point, the value of the function is going to be equal to your amplitude. So on the positive side of my function, so halfway between 0 and pi over 6, I know that I'm going to have a y value of a, which is 2. And then halfway between my x-intercept and my vertical asymptote at negative pi over 6, this is going to have a value of negative a, so negative 2. Now once you have those values, you want to connect. You don't want to just draw a straight line here because the tangent function has like a curve. So it kind of looks like your cubic function. So you want to draw a slight curve going upward, and then you want to draw it up towards the asymptote. And you want to do the same thing down here. So you want to draw a slight curve down to your point and then continue it very close to the asymptote. And there we go. We have one period of our function. And let me just show you how to draw another period. So again, our vertical asymptotes are going to occur at odd multiples of pi over 6. So our next asymptote is going to occur at 3 pi over 6. And it's going to follow the same pattern. Your x-intercept, it's going to be at the center of that region. And then halfway between your intercept and the asymptote, that value is going to be equal to your a value. So over here, the y value will be equal to 2. And then over here, the y value is going to be equal to negative 2. And then we want to graph it in the same manner. You want to have a curve up to your point and then continue along the asymptote. Same thing with the bottom curve down to your point and then continue down your asymptote. Lastly, we want to describe the graph as a transformation. Our a value is your vertical stretch or shrink, and because your a value is greater than 1, this is a vertical stretch of 2. And now for your horizontal stretch or shrink, we want to take the reciprocal of b. So the reciprocal of 3 will be 1/3, and because 1/3 is less than 1, we have a horizontal shrink. Let's do this a few more times. For monitoring progress 1, we are going to graph g of x is equal to tangent of 2x. Because we do not have a coefficient in front of our function, our a value is 1. And that's going to tell us what the y value of that halfway point between the x-intercept and the asymptote is going to be. And let's find our period. We want to take pi and divide it by your b term. You get a period of pi over 2. And we want to take half of your period because that tells you where your vertical asymptotes are going to be. Half of pi over 2 is pi over 4. Now let's draw vertical asymptotes at those x values. Now we want to find our x-intercept. And that occurs at 0 because tangent, if we plug in 0, tangent of 0 is going to be 0. And then we want to graph those halfway points between the x-intercept and the vertical asymptote. And we know that those occur at our a value. So on the right-hand side, halfway between pi over 4 and 0, which is at pi over 8, our y value is going to be 1. And then halfway between 0 and negative pi over 4 at negative pi over 8, our y value is going to be negative 1. And then we just need to connect those points. And you want to draw towards the asymptote. Now we want to describe the transformations of our function. We do not have a vertical stretch or shrink because our a value is 1. And our b value, we want to take the reciprocal. Reciprocal of 2 is 1/2, so we have a horizontal shrink. Let's do this one more time. Next, we are going to graph 5 tangent pi of x. Our a value is going to be 5. We want to find the period. To find the period, take pi and divide it by your b term, which is pi. And this gives you a period of 1. And then we want to take half of our period. So half of our period is going to be 1/2. And we want to draw vertical asymptotes at those x values at half and negative half. And we want to graph our x-intercept. If you plug in 0, then you get 5 times tangent of 0. Tangent of 0 is 0. Function of tangent will have a point at the origin as long as you have no horizontal translations. Now we want to graph those halfway points. Halfway between half is 1/4, and we know that at these halfway points, the y value is going to be either 5 or -5. So on the positive end, at 1/4, you are going to have a point of 5, and on the negative side, at -1/4, you will have a point of -5. Once you have these points, you're just going to connect it. Don't forget, you want to draw a curve, and there we go. We have our graph of the function 5 times tangent pi of x, and then we just want to describe the transformations. We have a vertical stretch of 5 and a horizontal shrink of 1/pi. That's it for our lessons for today. Let me know if you have any questions, and come to office hours if you need help. I hope you have a wonderful day, and take care.